Hello, algebra class. Today we're doing lesson 2, equations with variables on both sides. So we'll have, for example, 5x plus 3 equals 2x plus 4. And we'll need to move the variables to one side and all the constant numbers to the other side. Now, whether you want to move all the variables to the left, which is, I think, most common, but it doesn't actually matter. You can move all the variables to the right and then move the constants to the left. Either way, you should turn up the same answer. It's just more common to see people moving the variables to the left. Actually, I think it just depends on which side you start with the most on. So if you have like 3 variable terms on the right side of the equal sign and just 1 variable term on the left side, I think you probably easier just to move that 1 instead of trying to move the 3 on the right. We'll show examples in just a minute. The learning targets, we're going to write and solve equations to model after real-world situations, and then we'll interpret parts of the expressions in terms of its context. So we're going to see basically what it's doing at that point. So we're going to look here. The Future Engineers of America Club, FEA, wants to raise money for a field trip to the Science Museum. The club members will hold an engineering contest to raise money. They are deciding between 2 different contests, the Straw Bridge contest and the Card Tower contest. I think that's basically the Straw Bridge contest is where they can see who can build the biggest or most elaborate bridge just using like plastic straws. And the Card Tower is to see who can get the highest tower that doesn't fall over with like playing cards. The Straw Bridge contest will cost the club $5.50 per competitor plus $34.60 in extra expenses. The Card Tower contest will cost $4.25 per competitor plus $64.60 in extra expenses. So, Straw Bridge, you can already see, more expensive per competitor, but cheaper in extra expenses. Card Tower is less expensive per competitor, but more expensive in the extra expensive part. That's the first thing I would notice. To help decide which contest to host, club members want to determine how many competitors they would need for the cost of the 2 contests to be the same. So part 1, write an equation that sets the cost of the 2 contests as equal. So we want to see the point where they're going to cost the same amount of money. We're going to set the 2 equations as equal. So 5.5, which is 550, just shortened without the 0 at the end since it drops off when you round per competitor. Let's say C is our competitor, plus 3460. Again, we can just delete that 0 right there and make it a little bit shorter, 34.6. We're going to set that equal to 425 per competitor, C, plus 6460 or 64.6. This would be the equation that we would set the cost of the 2 contests as equal. First, Straw Bridge equal to the Card Tower. Solve the equation from item number 1 by using the algebraic method, showing each step and listing a property of equality, or provide an explanation for each step. So let's look. We'll see if I can copy and paste this just to make it slightly easier. All right, so we want to multiply, they say, the first step is each side by 100. Now, why do we think they're doing this? Well, I would tell you that I think it is to get rid of the decimals, to make it easier numbers to work with, so you won't have to eventually divide or by decimals or something like that. If I multiply by 100, the one with the most decimals here, 4.25 in the hundredths place, can be sure to be taken out and changed into a whole number by multiplying by 100. So if you just multiply everything by 100, it should make all the decimal terms turn into whole numbers. So the first one would end up being 550 C plus 3,460. That will equal 425 C plus 64, or 6,460. We just multiplied all the numbers by 100. Now, the next step, we want to move everything that's a like term to one side so that we can combine like terms eventually. So, as I said, we can either move all the variables to the left or all the variables to the right. As long as it's on the opposite side of the constant numbers, it would be fine. Let's just move them to the left. So we will, since it's 425C here, to get rid of it, you would want to subtract 425C from both sides. Because that's our subtraction property of equality. Or you could just say subtract 425C from both sides. You don't have to put all of this. I would like you to know that it's a subtraction property of equality, but saying that you're going to subtract 425C from both sides would be okay. So what happens? Well, let's do our commutative property so that we can put the numbers together. So that it's easier to subtract combined like terms in just a second. Commutative property. Right. So let's subtract 550 C minus 425 C. 550 minus 425 should be 125 C left over, plus 3460. That will equal 425C minus 425C is 0. It just equals 6460. Combine like terms. We still have two things that are not the same on one side, so we need to remove this one. Again, subtractive property of equality, we're going to subtract 3460 from both sides. So that will leave us 125C on the left And that will be equal to 6460 minus 3460, which would just be 3,000. Combining like terms again. And the next step, I will need to get rid of the 125. Let's divide both sides by 125. Remember, we got to keep it balanced. So what we do to one side, you need to do to the other to keep it even, which means matching and balanced. That's the division property of equality. And then we can just say 125 divided by 125 is 1 C left, and that will equal 3,000 divided by 125. So 3,000 into 125 into 3,000. So let's do that right here. It's going to look a little bit messy since I'm drawing it, but I think you can get the idea. $125 goes into 300 two times for 250. You would subtract and have 50 left over. Bring down your 0. 125 are going to 500 4 times, which is 500. 500 minus 500 will be 0, no remainder. So C, it will equal to 24. If there are 24 competitors, it will cost the same amount of money to do card tower and straw bridge. Interpret the meaning of the value of X in this problem. Hold on, notes. X is the number of competitors. The FE Club estimates that there must be more than 30 competitors in that contest. Make a recommendation to the club explaining which contest would be better to choose and why. So we found out that they're equal at 24. But now they say they want to have more than 30. So we're going to need to figure out which contest would be the better choice or cheaper basically, if you go past 24 where they're equal. One of them will start to cost more than the other. It's not the one we want. We want probably to pick the cheapest one. So let's set it up where we have our straw equation expression right now, but equation in the future, and our card expression for when there are 30 competitors. Remember, I put C for competitors a while ago. They put X in this question, but it's the same thing. As I said before, you can pick which letters you want to make as the most sense to you. It's only when they provide you with the letters that you need to work with what they have. Right now I'm just doing C. It's the same as X. So if I replace C with 30, it would be 5.5 times 30 plus 34.6. 5.5 times 30 is 165 plus 34.6, and that will equal 199.6. That's going to be how many dollars it costs. Let's look at over here on the card. It'll be 4.25 times 30 plus 64.6. 4.25 times 30 is 127.5 plus 64.6, and that will equal 192.1. $192.10, basically. I can put the zeros on the end to make it look better. And so, make a recommendation to the club explaining which test would be the better choice. If they're going to have 30 people, card contest would be cheaper. Card contest would be cheaper, would cost the least amount of money for 30 competitors, or even more than 30. They were even at 24, we saw. The card one will just keep being cheaper after that. Before 24, it would be more expensive to do the card contest and cheaper for the straw one. But after 24, the card contest is cheaper competitors. Number 5, the FEA club will charge each competitor $10 to enter the engineering contest. Write an expression for the club's revenue if competitors enter the contest. All right, write an expression that FEA will charge each club $10. All right, so $10 times the number of competitors, 10C. Done. That's my expression. Everybody that enters, they charge $10. So for 10 people that entered, it 10 times 10, $100 is what they would have. Part 6. A. Write an equation to find the break-even point for the fundraiser using the contest that we recommended to the FEA club. We recommended the card contest, so 425C plus 64.6. Oops, stop writing. 425C plus 64.6. Let me make sure to, yes, 425C plus break-even point will need to equal charging everybody $10 that enter. $10 points 10 times C. So this is, remember, this equation was how much it costs to do the card contest. We want to find the break-even point for when they're charging everybody that does try it $10. B, solve the equation and state a property for each step that we do. So here is our equation. Let's copy it and paste it real quick just to make it a little bit simpler and faster. Now, let's solve this and find out how many competitors needs to enter for the club to break even, to make as much money as they are losing doing this contest. So we want to move all the variables to one side. Let's just, for giggles, pick the right side. So I will start by subtracting 425c from both sides to get rid of it on this first side. I'm not doing the whole multiplying by 100 to get rid of decimals because I think we can all work with decimals, especially if you use the calculator, which your phone or your computer should be able to access. Or you may have a physical calculator. And this was our subtraction equality property. .425c minus 425c is 0, so we're left with 64.6. 10c minus 4.25c will give us 5.75c. Combining like terms. Oop, tabbed out. We will divide both sides by 5.75 to isolate the variable on one side, so it is by itself. And that was our division property of equality. Now we use our handy dandy calculator to see what is 64.6 divided by 5.75. It's going to be 23 if we round. If you wanted to be exact, it is 11 and 27 over 115. If you didn't want to work with decimals and wanted to change everything to fractions, today we're just going to round and make it easy on ourselves. So basically, you have to have 11.23 competitors. You can't really have 0.23 of a person entering. So we're going to round again and say that they really need to have 12 competitors to break even. How much profit will the FEA club earn from 32 competitors if they use the contest that we recommend? So we're going to look at our equation that we set up. And we're going to replace C's with 32. And we're going to see what it comes out to be. 4.25 times 32 plus 64.6 times 10 times 32 . 4.25 times 32 is 136. plus 64.6. That's going to be equal to $200.60. I'm going to break these two down separately. 10 times 32 is 320. So we want to take, it costs $200.60. We're making $320. So we just subtract these two numbers to see how much of a profit we're making. 320 minus 200.60. 320 minus 200.60 will equal $119.40. I probably wrote this one in just a little bit of a confusing way right here. I should have separated these two right here so that you can see what we were talking about. Future Engineers of America Club treasurer was going back through the fundraising records. On Monday, the club made revenue of $140 selling contest tickets at $10 each. One person sold 8 tickets, but the other person selling that day forgot to write down how many she sold. Writing solving a question determined the number of tickets the other person sold. All right, so we know that they made $140 of revenue. And if we go back up, we can see 10 times the number of people that bought tickets. That's going to equal 10 times one person sold 8 tickets. The other person sold, we don't know how many tickets. That should be adding. So we work this out. Now we can distribute this one now, 10 times 8 and 10 times x, or we can get rid of it now by dividing both sides by 10 to just get the parentheses by itself. Let's do that. 140 divided by 10 will equal 10 divided by 10 140 divided by 10 is 14. 8 plus x. We can get rid of the parentheses. There's nothing around it now. 10 divided by 10 was 1. 1 times the parentheses. It's just that parentheses. We can subtract both sides by 8. In our next step, we can subtract by 8. 14 minus 8 is 6. 8 minus 8 is 0. We're just left with x. So the other person must have sold 6 tickets. Go ahead and try 9 through 15 on your own to see if you understand writing the equations down and working them out when sometimes the variables are on both sides.